Hello, everybody. It is November 3rd, an asynchronous lesson, and we're going to talk about transformations as functions. So first, we're going to begin with a little function review. And in chapter 1, you learned that a function assigns each input to a unique output. And that's sort of the general definition of function. Most of the functions involved equations like this. F of x equals 3x minus 5. Read those parentheses as f of x. F is the name of the function, X are the inputs, and then here's some operations I do to my inputs. In this case, my function is multiplying by 3 and subtracting 5. These functions took input numbers, the X values, and assigned them exactly one output number. Okay, so for the input X equals 2, what is the output? F of 2. Well, to do that, you substitute 2 in for x, so f of 2 equals 3 times 2 minus 5. So the operations, they multiply first, order of operations, I get 6, minus 5 equals 1. So that f of 2 equals 1. So the input for, and when you have input 2, output is 1. Okay, let's look at a function on a graph. So here is a function, g of x, it's named g of x, it's over here. This is a representation of that same kind of relationship we just showed, where the inputs are my x values and the outputs, g of x, are the y values. So sometimes we say that g of x equals y. So for the input 3, what is the output f of 3? All right, let's take a look on the graph. So x is the horizontal axis. I go to 3, and then I see where I have to go to hit that function. And I have to go to -1. So f of 3 is -1. The domain for this function, just to talk about domain, are the possible inputs. If I look at the directions, this keeps going in each direction, so all x's are possible. So my domain, my inputs are all possible numbers. The range, however, is limited, because if I look down here, it doesn't go below -1. So that my range, or my y values, has to be that the values greater than or equal to -1, or y is greater than or equal to -1. All right, on to some transformations. So rigid transformations. In this chapter, you're studying functions that assign each point in the plane to a unique point or image. So that's that function that goes from one value, there's an input and an output, but in this case, we're inputting a point. These functions are called rigid transformations or motions because they move the entire plane, the entire sheet of tracing paper with any figures you have drawn, so that all the figures remain unchanged. Therefore, angle measures and segment lengths are preserved. We keep the x-axis and the y-axis on an underlying plane in the original position for reference. There are 3 basic rigid transformations that we're going to consider: reflections, translations, and rotations. All rigid transformations are some sort of combination of those 3. So for a reflection, when a figure is reflected across a line of reflection, such as a figure at the right, it appears that the figure is flipped over the line, looking like a mirror image. The mirror line is a line of reflection, L, shown in the diagram. However, formally, a reflection across a line of reflection is defined as a function of each point A to a unique image point A prime, so that the segment connecting the points is perpendicular to the line of reflection. On the segment, the distance to the line AP and then PA prime, those are equal. So it's kind of same length on either side. For a rotation is a turning. A figure about a fixed point is called a rotation. It can be rotated either clockwise or counterclockwise. Formally, a rotation about a point is a function that assigns each point P in the plane to a unique image point P prime, so that all angles of rotation have the same measure, which is the angle of rotation, and that the segment, the distance from the OP, so the point of rotation to P, and then OP prime are the same. A translation. A translation is like sliding a figure. Formally, a translation is a function that assigns each point Q in the plane to a unique image point Q prime, so that all line segments connecting a point with this image have equal length and are parallel. So it just slides it over and moves at the same length. All right, that's it for today. You all have a wonderful day, and I will see you soon.